Yes, dear friend, in last video I explained you laws of electroconduction. One was Faraday law, other was Lenz law. Faraday law gives the magnitude of induced EMF in closed circuit or also across the end of conductor, while Lenz law is basic law to find the direction of induced current or induced EMF. And here we say that how the Lenz law is derived. So question asked in exam, कि Lenz law is the direct consequence of law of conservation of energy. And now here you may be thinking that where the concept of energy has come here. In electric circuit, I told you when current pass through conductor, heat is produced and heat is also for energy. So generation of current means generation of electric energy. Now how the Lenz law determines the direction of current? Suppose in this figure, magnet is moved toward the loop. So ultimate cause of induced EMF, induced current or induced EMF is the cause by virtue of which it is produced. So what is the ultimate cause of induced EMF or current? Change of magnetic flux. Change of magnetic flux. So here when we bring the magnet close to this, then flux increases. So because this magnet, movement of magnet toward the loop, increasing magnetic flux, then this flux should not increase. So the induced current in the loop should be such that it produces magnetic field opposite to the direction of field due to magnet, so that flux remains constant. And hence current should flow anti-clockwise here. Because you know current flows anti-clockwise, field line comes out of this and clockwise into. And if magnetic field lines are, the magnetic line outward and hence this phase, the phase facing the north pole of magnet will act as north pole. And this north pole of induced magnet will oppose the motion of magnet toward the loop. It means the magnet will not go itself. We have to push it. And in pushing the magnet toward the loop, work is done. Suppose the loop is fixed here. Anyhow. If you can suppose that this is not there, current will flow only either clockwise or anti-clockwise. If current flows clockwise, then what will happen? South pole will develop there, which will attract itself, and then energy is created itself, which does not take place. This is against law of conservation of energy. That way, here we can say that Lenz law is a consequence of law of conservation of energy. If we take it away, then flux will decrease. Now the current in the loop will be such that it will not allow the flux to decrease, so current should be clockwise, so that field in the same direction, and it means there will be south pole, and that south pole will attract. Again we have to do work in carrying the magnet away from the loop, and this work done here appears in the form of electrical energy. So I think you have got. May I repeat again? If we carry the magnet toward the pole, toward the loop, so flux is increasing. Then induced current here will produce a flux. If it is positive negative flux, means field line will come out. If they come out, field line come out, then facing the north pole will act as North pole, and North pole repel North pole. So we have to do work against the repulsion force, and hence energy obtained, electric energy obtained on the cost of mechanical work done on the in moving the magnet. Similarly, if we take it away, flux will decrease. Flux decrease means current induced will be there, will produce magnet in the direction of field of the magnet, and hence the phase will act south pole. That south pole will attract the north pole, and hence work will be done against attractive force to carry the magnet away, and that way work done appears in the form of electric energy. So that way law of energy is not violated here, and hence we can say that Lenz law is bad consequence of law of conservation of energy. Now there are many questions. How do we apply Lenz law to find the direction of induced current? Suppose here I represent magnetic field by crosses. This crosses means magnetic field is normal to plane of board and into it. Only if I take a electron loop, conducting loop, and move it into the field. Here I take this, any other loop, may be rectangular or circular, like this. If it is circular, here move it is 1, 2 and 3. All are conducting loops. So what will be the direction of induced current in loop 1? You may be told somewhere right hand thumb rule. In fact, that is not a universal rule. That applies only one case. There are many examples I will tell now. Only Lenz law is universal law or basic law to find the direction of induced current. How here? When this is entering this, so magnetic field line increasing in the loop, the flux is increasing. This field is into this. So induced current here will oppose the increase of flux. That will be on positive. Induced current here should produce magnetic field opposite to the applied field. Means field line should come out, and it is only then current flows anti-clockwise. There is no need of applying right hand thumb rule. See what is the ultimate cause of induced EMF. The ultimate cause is change of magnetic flux. So when this loop coming into this, then flux is increasing. This flux is into negative flux. So positive flux will be there only when the current induced in the loop produce a magnetic field whose direction normal to plane of paper and outward. So anti-clockwise. Here it is going away. Here flux is decreasing. So the induced current will help the flux to remain same only if current flows clockwise and field into this. Again, it is also there into going into this. So flux should here increasing, so it should decrease to anti-clockwise. So Lenz law help you in telling the direction of induced current. Now I take some other example, although difficult here to those diagrams. You have seen solenoid. It is solenoid here. ऐसे बनाऊंगा तो मैं ऐसे नहीं सुन Now on the same core, it may be over this insulating wire होते हैं. Suppose so current is this way, flowing this way. If I move this side, rheostat, so what is happening? Resistance decreasing, current increasing. Too many questions comes together. If this is a rheostat device which controls the flow of current. If I move this switch here towards the positive terminal, the resistance is decreasing, so current will be increasing here. So in which direction current will flow in this conductor C? In which direction the current will flow in conductor C? So here right hand thumb rule does not help. Actually कोई वो लो है ही नहीं, पता नहीं कहाँ से किसने घड़ दिया और लोग उसी को पकड़े बैठे हैं. तो this mandible of this solenoid, you know from the last chapter, will be pointing this direction. It will be like this. Is not that? From right hand palm rule. Or it is clockwise to south pole, here anti-clockwise north pole. And when this current is increased, so flux mandible will increase because B equal to mu0 Ni and the conductor length. So induced current here is there because field is increasing, flux is increasing. So that will help. The induced EMF will not allow the flux to increase only when mandible of this is this direction. यानी कि if we hold this like this, तो ये यहाँ पर करंट नहीं होगा भाई. देखो ये वाइंडिंग अपोजिट है ना भाई. अगर हमको फिर यूँ पकड़ना पड़ेगा इसको, तो यह करंट इज दिस वे ना भाई. तो it will flow from BCA direction. By increasing the current, by increasing the magnetic field, that increasing field will be producing increasing magnetic flux. Increasing magnetic flux. So in this, the current will, induced current will not allow the field to increase. So it will fill in the direction. And here right hand palm rule says that current will flow this. If I carry this direction, then it will be producing the field the same. Then it will be like this. Is that clear? So that way Lenz law help us to determine. In NCERT book there are lot of example here. It is page 229. On page 229 there are F, A, B, C, D up to F part. तो C part तो like this जो मैंने बनाया है, ये मैग्नेट मूव कर रही है, ये वाइट साइड मीन्स साउथ पोल विल बी देयर like that. So you try this question from NCERT book, and there are many questions here. So Lenz law is basic law to find the direction of induced current. Now, I told you that change of magnetic flux per time induces EMF, and due to that EMF circularly closed current flows. Now we will learn here methods of creating EMF. Okay, my way of teaching here is that you should know, think clearly. It is very essential.